Okay, today's lesson is 12-3. It is trigonometric functions of general angles. So what we have talked about so far are basically those trig functions from the unit circle. And just to refresh your memory from our unit circle, okay, every point was related to the coordinates x, y, and we knew that the x coordinate told us the cosine and the y coordinate told us the sine. Okay, that was because we were on the unit circle and our radius is 1. Well, now we're going to talk about other angles. Okay, these angles are still in standard position, but they're going to pass through a point xy. Here's a picture of it right here. And the key to that point being xy is that means that r is not necessarily 1. So this can hold true for any angle, no matter what it is. But what's important about this point, xy, is that is still x and this is still y. So x is going over, y is going up or down. This right here is my theta. Okay, actually, you know what we say? We say it's, I didn't mean to do that. Let me go put this on there. Okay, sometimes we actually refer to this as theta prime because theta, this is an angle in standard position because its initial side is the positive x-axis and its terminal side is another ray. Okay, so this is theta. When we have theta here, this is going to be the angle that it's made with the x-axis, and that's what's going to allow us to find what these trig functions are. So using your Pythagorean theorem, you might be more familiar with knowing that x squared plus y squared equals r squared. Well, that means that r equals the square root of x squared plus y squared. So however you choose to remember, okay, this is a very, very important relationship that we're going to use a lot to do these problems. Okay, so that being said, if we define our 6 trig functions of any point xy, then we know that the sine of this angle is opposite over hypotenuse. So we say that the sine of theta is y over r. That makes the cosine of theta x over r, and the tangent of theta y over x. Of course, x cannot be 0 because we cannot divide by 0. Okay, now keeping in mind the reciprocals that might be a little bit new, and remember I told you they don't start with the same letter. So if they don't start with the same letter, if this is the sine, then the cosecant is the reciprocal of the sine. So the easiest way to find that is just to take and flip my sine. So instead of y over r, I have r over y, where y can't be 0. Secant is going to be r over x, where x can't be 0. And cotangent is going to be x over y, where y cannot be 0. Okay, so let's look at what you have to be able to do with that information. Put that right there so you can see it when we do the problem. Okay, so the terminal side of theta in standard position contains the point -6, 2. Find the exact values of the 6 trigonometric functions. Okay, so this right here is my x and y. And these are how, oh, can't see it up there because I'm using my stylus. This up here is how we define all those trig functions in terms of x and y. Oh, I need r. How am I going to get r? I'm going to go x squared plus y squared equals r squared. That's my x and y. And we've had this a lot before, so I hope you remember that if there's ever a negative and we square it, it's always positive. So when I write the next line, I don't put the negative on there because I'm telling you, I see it over and over again. Students who put the negative, if you do not put the parentheses, they mess up the problem. So just know you're squaring it, so I don't have to worry about the negatives. That leaves r squared to be 40, and r equals the square root of 40, which is 2 square roots of 10. Now, it is plus or minus, but r is always positive, so you don't have to worry about plus or minus. The plus or minus is going to come into effect when we use the x or the y value of our problems. Okay, so I need to pause 1 second. So let's see if I can do that. Cool. I had to make sure that I had my, I don't know what's going on. Sorry, I hope you enjoyed that scenery. This to find all of our trig functions, I actually wanted to show you how to use ClassCalc, so I wanted to make sure I had it open for you. Okay, so first off, I'm going to write the values of my trig functions. I've got the sine, cosine, and tangent, and then I like to go ahead and write my reciprocals with that. Sine, okay, remember I just said it doesn't start with the same letter, so sine and cosecant are reciprocal, cosine and secant, tangent and cotangent, okay? So what is the sine? The sine is y, which is 2, over r, which is 2 square roots of 10. So I would encourage you to go ahead and write that over here. Let's see, I wrote it right there. 2 over 2 square roots of 10. If you do not know how to do this, okay, have ClassCalc handy. 2 divided by 2 square roots of 10 equals, gave me a decimal, but I can click on here and say, give me the square root. And it tells me that it's the square root of 10 over 10. And that's because, in case you can't see, those 2's are going to cancel out. So this does become the square root of 10 over 10. And I'm going to tell you in a minute why I want to keep this written here. I want you to keep 2 over 2 square roots of 10. Have it handy. Okay. What is my cosine? Cosine is negative 6 x over r. So it's negative 6 over 2 square roots of 10. So I'm going to put that in. If I put that into ClassCalc, it's going to simplify it to negative 3 square roots of 10 over 10. Tangent is y over x. And how does that simplify? Negative 1 over 3. So if you have any trouble simplifying those, please use ClassCalc. Have it on your phone. Have it open on another tab on your Chromebook computer. Okay, so the reason that I had you write this is because if you will leave it like this, then when you have to go do the cosecant, you just have to flip that. And when you flip that, that means 2 square roots of 10 over 2 is going to become the square root of 10. And 2 square roots of 10 over 6 is going to become this negative square root of 10 over 3. And of course, negative 1/3 becomes negative 3. We don't leave it as negative 3 over 1. So that is our problem. And that's all that you got to be able to do. Okay, so let's look at the next thing that we got to talk about, and that is something called quadrantal angles. Okay, quadrantal angles are those angles that are not in a quadrant. Okay, or another way to think about it is an angle whose terminal side is an axis, a multiple of 90 degrees or pi over 2. So if you want a better picture of that, if you were to draw it, okay, they're the angles that are going to be here. These are your quadrantal angles, which means always one of your coordinates is going to be, I hope you're yelling at me and telling me, it's always going to be 0. Zero is either going to be last or first. It's going to be one of the coordinates of your problem. Okay, but just like we did the last one, you can still, or need to remember that you can still apply what we did to the last one. So I'm going to go ahead and do that. So first off, we have x is negative 2 and y is 0. So then I'm going to go down and put in x squared plus y squared equals r squared. X, I'm putting in positive 2 because I know when I square a negative, I get a positive number. So 2 squared plus 0 squared is r squared. R squared equals 4. And r equals, again, plus or minus 2, but r is always positive. The negative comes into effect with your x or y. So if we write our trig functions, we got our sine, cosine, and tangent. And the reciprocal functions are cosecant, secant, and cotangent. So my sine is y over r. Okay, what is y? 0. 0 over 2 is 0. Cosine, negative 2 over 2 is negative 1. Tangent, y over x. 0 over negative 2 is 0. Okay, cosecant is the reciprocal of the sine. So if I did 0 over 2, now I'm at 2 over 0, which is undefined. The reciprocal of negative 1 is negative 1, and the reciprocal of 0 we just did is undefined. So there you have your problems for quadrantal angles. Okay? Now, the next thing we have to talk about is something called reference angles, very important. And if you have a unit circle handy, you might not think it's important to know these reference angles, but I promise you they will come back to play later in your study of math. So it is important to understand them. So what is a reference angle? And I promise you, if you will say this every time, just remember this definition, then you will always know how to get the right answer. Okay, so what is the reference angle? It is the acute angle. What's an acute angle? Angle between 0 and 90. The acute angle that a terminal side of an angle in standard position makes with the x-axis. That is a reference angle. Okay, it has to be between 0 and 90. Means it's always going to be positive. Okay, now if it is also made with the x-axis, okay, if this angle is always made with the x-axis, then the numbers that we're going to use to find the reference angles are going to be those numbers on my x-axis. And what are the numbers on my x-axis? This number is 180, and all the way around is 360. So every time you're going to find reference angles, you're going to use 180 or 360 if you're dealing with degrees, pi or 2 pi if you're dealing with radians. Never ever use 90 or 270 because that's not what the definition of your reference angle is. It has to be made with the x-axis. So look at this first problem. We have negative 110 degrees. The first thing we're supposed to do is sketch the angle. So I'm going to go sketch the angle. We've got negative 110 degrees. Remember, we find 110, okay? This is 180. So 110 is up here. But if it's negative, then we just have to flip it over the x-axis to make it down here. Or you can think of it this far in that direction is the same as this far in the opposite direction because the negative tells us it's opposite. Okay, so the reference angle is the acute angle made with the x-axis. Okay, this angle right here, y'all, is not acute. Okay, this angle right here is acute. So this is my reference angle. And as I said, you're going to use 180 or 360. And I will tell you, I'm gonna write a little thing on here because I think this will help you. If your angle is in the second or third quadrant, oh, you know what? This is crazy. Oh, I know what it is. If your angle is in the second or third quadrant, you're going to use 180 degrees. If your angle is in the fourth quadrant, then you're going to use 360 degrees. I just put it over there. I can put it right here because that example is radians. So if your angle lands, if the terminal side of your angle lands in the second or the third quadrant, use pi. If it lands in the fourth quadrant, you're going to use 2 pi or anything more than that. Okay, so to continue with this, I'm trying to find the measure of theta in my problem. I'm going to use 180. So I'm going to take 180, find the difference between 180 and 110. And the difference between those is 70 degrees. So the answer to my problem is 70 degrees. Okay, 2 pi over 3, excuse me. 2 pi over 3, what quadrant is it in? Hope y'all are all telling me that it's in the second quadrant. That is 2 pi over 3. This is my reference angle because that is the acute angle made with the x-axis. So I'm going to use pi and I'm going to subtract 2 pi over 3 from pi. Pi is the same thing as 1, or if you want to use your calculator, class calc to do it, you would do 1 minus 2/3 and then put the answer back in your problem. So in this case, my answer is going to be pi over 3. Okay, now why is it so important? Because let me tell you what you can do with reference angles. If they were asking us to use a reference angle to find the trigonometric function, the value of the trigonometric function. So if I have the cosine of 135 degrees, then I know it's in the second quadrant. If it's in the second quadrant, then I'm going to subtract it from 180. So 180 minus 135 is 45. And what is the cosine of 45? It is the square root of 2 over 2. However, I'm in the second quadrant, so that's why it's negative. So the reference angles basically help you figure out what your value is, and then the quadrant is telling you whether it's plus or minus. So when you have to memorize the unit circle, if you know that first quadrant and you know where things end up, then you know what your answers are. Okay. The beautiful thing about radians, y'all might not like them so much yet because you haven't been using them very much. But the thing about radians is the reference angle on our unit circle. If it's on our unit circle, the reference angle is whatever that denominator is. So my reference angle is pi over 6. So I'm going to think to myself, what's the tangent of pi over 6? Tangent square root of 3 over 3. But what quadrant is that in? I did not write it, so I'm going to write it again. It's in the second quadrant, and in the second quadrant, the tangent is negative. So my answer is negative square root of 3 over 3. Again, I'm doing this without a unit circle, so that's why it's helpful to know how to do these things. Okay, or to use your reference angles. All right, last problem that I want to do is one in your homework, and some people get stumped on it, so I kind of wanted to show it to you. It's like the first problems, but the difference is they gave you one of your trig functions and are asking you to find all the rest of them. So I'm going to go up here and get you started and show it to you so that you don't get stuck while doing your homework. So if I have the tangent of the angle is negative 2/3, and it is in quadrant 4, the negative 2/3 is basically telling me in terms of x, y, and r that is y over x. Quadrant 4, I know that the first number is positive and the second number is negative. That's why my tangent is negative. But what that tells me is that my sine, or my y coordinate, is negative in this case. So I still need to find r. So I'm going to come down here and say x squared plus y squared equals r squared. I'm going to plug in my values, find out that r squared equals 13 and r equals the square root of 13. So when I come over here to put in my trigonometric functions, sine, cosine, and tangent, and then I have cosecant, secant, and cotangent, okay, my sine is y over r. So remember, y was the second coordinate. We're in the fourth quadrant, so my y is negative. So that's negative 3 over the square root of 13. And whether you do it by hand or use class calc, that becomes negative 3 square roots of 13 over 13. But if you keep it like that, then when you have to go find the reciprocal, it's easy just to flip the original one. But you cannot leave a radical in the bottom, so make sure you don't do that in any of your answers. Cosine is x, which is 3 over the square root of 13. When you rationalize that, it becomes, poo. That's supposed to say, did I do those backwards? I did do those backwards, y'all. Okay, pause 1 second for me, please. Okay, so I fixed that. And so that means that I'm going to write this one. So this one would be the square root of 13 over 3. And fortunately, I had these right because that's what the original problem was. So you flip it. So that ends our problems. I'm glad I fixed that easily at the end of the video so I didn't have to re-record everything. I hope y'all are doing well. Please email me or join me in a meet if you have any trouble or any questions, especially before you take your quiz. Thank you very much, and y'all have a great day.